Okay, ladies and gentlemen, thank you for coming. Not feeling great today? If you can't hear me from where you're at, you might want to move a bit closer. Not too close, though, for obvious reasons. During office hours, I'll put the mask on. You should be fine with that gap. Oh, I thought I was going to make it. Hardest semester I've had in a long time. I thought I was going to make it. 3 months in, I hadn't gotten sick yet. Then it hit me. It's going to mess up my voice for the showcase, maybe. We'll see. We will see. So, today, a little bit of a chill day. Most of you have not started homework 8. A few of you have. Some of you have gotten the first suite finished. It's a pretty easy one, okay? Adding the new vector2 data type, okay? Not too bad. Not too bad. Adding the meta methods so that data type can be used with the plus, the minus, the multiplication operator, okay? Powerful stuff. A big part of making a good game engine is just making it convenient to use. So the small things might be annoying for us, but for our users, they really mean a lot, okay? Anyway, all right, let's go ahead and get to it. We have more than a week to finish homework 8. You've got about a week and a half, a little bit more. I encourage you to get started if you can, okay? I have a game engine for you. This is another one of those very, very opinionated, very custom game engines, okay? This is Twine, all right? So Twine is an engine dedicated to stories-based games, dedicated to what the creator calls hypertext stories. These are stories with additional interactivity, with additional media in them. Okay? Created in 2009 by Chris Klimas. It's a very, very easy system to use. In fact, it can run in your browser. You're going to see it right here. See? Boom. We have 0 stories. This is Twine. I'm using it in my browser. We have 0 stories. I click new. What kind of story you want to make? Eeks 498 Adventure. Okay? And now we have our main editor UI. Okay? If we want to write a story, we got to double click these passages. These are kind of the units of our story. And we can type into a passage to create content there. We can also add images. You can even add HTML code, which really opens up Pandora's box as far as customizing all this stuff goes. Well, let's do something. Okay, what's the story? You arrive at the Viz studio for another lecture of Eeks 498. Let's make it a little bit more interesting. It's a dark and stormy evening. Okay? Now, what I want to do is I want to create a branch, okay? Where should our story go? Let's give the player a choice. What do you think? Give me some action the player could take once they arrive here. What do you got? Let's go. Come on. Take the quiz. Okay? Take the quiz. Okay? And what's going to happen after writing that is that I have a new passage called Take the Quiz, and I can write into it. The thing, though, is that there is no quiz today. Okay? And maybe we can do something like, I don't know. Actually, let's name this passage right here. Let's go to the start passage, okay? Take the quiz. Well, we want to be able to go back to that start passage, okay? So now you see we're creating this kind of a cyclic graph that represents our story. Okay, what other options do you think we might want to give the player? What do you got? Come on.
Work on homework 8.
Work on homework 8. All right, we got a new passage. You begin working on homework 8, but this causes you to miss the lecture. The end. Okay. Lecture. Making everything harder. Okay, the end. All right? Okay, now, what we can do here is once we want to actually test this game, it's very easy. We just kind of click on that Start tab. We go Test from here. Okay? We've got this little debug panel right here in the corner. This can actually show us if we have any variables. Well, what are the values of those variables? Okay? I'm going to get rid of it, though. It's a dark and stormy evening. You arrive at the Viz Studio for another lecture of Geeks 498. We're going to take the quiz? Let's do it. There's no quiz today, so let's go back to the start. We're going to work on homework 8. All right. You begin working on homework 8, but this caused you to miss the lecture. Okay, the end. Okay. We have, in just seconds, we have our own basic story. Okay, interactive story. And you can imagine putting a lot of time into cool images and other stuff. There's lots of things you can customize. Interestingly, the engine has some built-in features. For instance, the ability to go back, okay? Undo. Now, you can get rid of that if you want to, okay, if you want to make a more hardcore experience. But it's a pretty fun time. This is the engine we used in our freshman level Intro to Creative Process course, in which freshmen of all disciplines, artists, writers, engineers, were to make a game together, right? And we used it because of how simple it is, how easy it is to use. Okay? Its features are somewhat limited until you really break out the web tech. But in a way, that's an advantage. Okay? You eliminate expressiveness, and you can get simplicity sometimes. And sometimes that's worth the trade-off. Okay? One game here I'm going to show you is a game called You Are Jeff Bezos. This is a top game on itch. Okay? Here you can see an example of variables in Twine. You see we have a variable, 150, what is that, billion? 156 billion? All right, not bad. When you wake up this morning from unsettling dreams, you find yourself changed in your bed into a monstrous vermin. You are Jeff Bezos. So you get an impression on, this might be a little bit of a cynical game, but let's give it a shot. Jeff Bezos' employees are now yours. His money is now yours. Nothing you say or do will convince anyone otherwise, even his closest friends and family. So what are we going to do? Use the restroom? We're going to sob in terror? We're going to go spend this money. I like that one too. What are we going to spend it on? We can repair. Oh, we can't. No, we can't pay the student loan debt. We don't have enough. Going to repair Puerto Rico? Going to pay for the border wall and then not build it? Pay personal taxes? Hire 100,000 new teachers for 4 years each? And homelessness? What are we doing? Repair Puerto Rico. All right, we're going to be very popular in Puerto Rico. You repair every ounce of damage Hurricane Maria has done to Puerto Rico. It will still take some time to enact repairs, and nothing can be done to bring back the thousands of lives lost. But the island is at last on its way to a recovery. 139 billion. This is roughly the limit of your personal wealth, so good thinking getting this one out of your way first. There's some smaller things we can take care of, okay? Uh-oh. No, there's not. What else? Double Amazon's employee salary for a year, maybe? Support 10,000 artists and residents. Abolish electoral college. I'm not sure how I'm not sure how that's going to do it. Pay back taxes to the EU. Fund NASA is not going to happen, sadly. All right. How are we going to do it? What's the play?
I support the artists for 2 to 4 years.
Support the artists? Okay. As long as they're doing game art. All right, we're going to support the artists. Universities, conservatories, each artist $50,000 a year. Geez. Okay. All right. Oh, geez. The lawyers beg you to force the artists to wear a sponsored by Amazon badge on their shirts. Okay. You fire these lawyers and retain our fees to fund a few more artists. Nice. Okay. All right. Right. So you can get a feel for what the artist is trying to say here when they made this experience, and you can feel that even though it isn't super visual, it's still pretty funny, right? Especially when you play it with people. Making those decisions is sometimes all you need. So it's pretty good stuff, all right? You've already seen the editor. It's very intuitive, very easy to use. One thing I'll point out is that this has a really great author postmortem, because I think this is now a decade or so old, or over a decade old. Yeah, definitely, by a long shot. And you can read on kind of what the creator, what their experience was when they created it, why they made certain decisions, and you can get the history kind of straight from the source. Okay? And so I encourage you to check out this reading if you want to. Okay? All right. Does anyone have any experience with Twine? Does anyone like it? Anyone used it? I'll tell you what, if you ever got to teach a summer camp or help with that or something, and you got a bunch of kids, can you teach them game programming? Probably not. Can you teach them to make Twine stories? Almost certainly. Okay? Maybe that or Roblox or something. Who knows? Okay? Kids are smart. They're way smarter than sometimes we think. Okay. All right, some reminders. I put this on the Piazza on Discord. Points for the quiz. Some points have been returned. If you messed up a question that was a bit suspect, you got some points back. And we're going to go through the quiz a bit today because the average was a bit rough on that one. Okay, the average was about 13. Okay, so we're going to go through. We're going to talk about not only the questions, but also the philosophy of how questions are designed. That might help you more for the exam, okay? But you may have gotten some points back. The autograder off date is Monday, April 8th, okay, at 4:30 p.m. Everything seems to be due at the start of class in this course. In all my courses, that's how it be. You know why that is? It's because, as soon as class arrives, I begin talking about the next assignment, okay? And that's a pretty natural point to close off the previous one. So that's why. If you say we're going to stop at 11:59 p.m., well, why not just give us a few more minutes? Why can't I go into midnight? It's not like I'm doing anything at 1 a.m., 2 a.m., 3 a.m., okay? Well, this semester I am, but usually not. Anyway, the takeaway here is that you're going to finish the exam on a Friday. Autograder off date isn't going to happen until the following Monday at 4:30. So you got, 3 days? You're going to have 3 days over the weekend, and then on Monday, most of the Monday, to do any final submits you want. Try and grab any more points from the autograded assignments that you want, okay? It's coming up, though. Be careful, all right? If you let things snowball a little bit and you got behind on some assignments, you can still make it, but you're going to have to put the pedal to the metal a bit, okay? And related to that point, the grades are looking a little bit rough for some of us in this course. That's a very common thing, okay? Don't feel like you're alone here. It's a tough class, tough topic, okay? There's no way you can make a game engine without facing some tough challenges, okay? Especially in just 3-4 months. And in particular, this is the first time the class is run, and so there's a lot of friction that won't be there in the future, okay? This is all to say that please remember, your graded and gradebook, probably not accurate, okay? There are probably going to be big curves and extra credit happening at the end of the semester. If you've put in a very good effort, I haven't decided exactly what that cutoff is going to be. I'll tell you this, I really want to see you get at least part way through homework 7, okay? You finish homework 7, that's a game engine right there, okay? Bona fide, okay? Maybe you don't quite get to homework 8, all right, okay? I want to see you get through at least part of homework 7. If you make it, you're not going to fail this course. It's not going to happen, okay? So don't panic if your grade's looking a bit nasty right now, okay? At the end of the semester, you don't know what's going to happen, okay? So just put your good effort in. You're going to be all right. But if you skipped most of the assignments in the course, that's not going to fly, okay? You should email me to decide what you want to do, whether you can make it up or whether you can late drop or something. Yeah, okay? So keep that in mind. There's no discussion this week. So on Friday, you will go to the room. There will be no one there. Now, there's usually no one there besides my staff. Okay? How many of you have been watching the lecture recordings, at least? Maybe. I see some of you looking at the lecture slides, discussion slides. That's good. This semester it's a bit tough because, especially in Homework 8, some of the stuff is a bit inaccurate, simply because the staff had kind of not a ton of data, because I just finished Homework 8. But anyway, so keep that in mind. Don't waste your time and go to discussion on Friday. The staff is at GDC, spreading the good word of Michigan game dev in San Francisco, and hope they stay safe and have a great time. I want to talk to you a bit about Homework 4. I think one of the most pragmatic things you can get out of this course is just you flat out know another language now. However, when I see the 13 out of 20, I'm not so sure. Okay? And this also applies to the exam, I recommend go write some Lua. Go do what we did in class together and go make yourself a game to get used to programming in Lua. Build up some muscle memory. Now, I'm not saying you're going to have to write Lua on the exam, but you're definitely going to have to reason through it, okay, at some point. So make sure that you're ready for that. Let's go ahead and go through quiz 4, okay? This is a tough one right here, okay? What is the constructor for what's the proper constructor for a class, okay? We're trying to basically fake a class-based OOP approach in Lua using tables and metatables, okay? The correct answer here is new 5, okay? You create an instance, which is just a new table, okay? We create an empty table. Now, if we want to set up an inheritance structure, the way you do that is with metatables. So you use the metatable function. But a metatable is a table. It's a table with certain special properties. And so this table right here is an empty table, but it has that underscore index value. That property is what the runtime is going to use to basically say, oh, I didn't find this function on this table, but there's a metatable set and it has that dot index. Oh, so I'm going to look at this other table to find it. Boom. Done. Okay? That's how it works. Some of these other ones are a little bit confusing. They might look okay. Like new 4 could definitely get me. But the thing is, character is not a metatable. It's just a table. Okay? This right here, because it has index, is a table. Okay? Yes?
So I understand the syntax, but is dot dot or dash dash index like more of like a pointer to the main character?
Dash dash what?
And then the underscore index like equals character. Is that just sitting like a pointer to character?
Yeah.
Okay.
Yep, pretty much. Pretty much. It's saying, hey, if we don't find the variable or function on this table, the current table, then go find it on this other table. When you alter things on this instance right here, you won't alter things on the inherited table, okay? You can think of this as kind of a read-only situation of inheritance, all right? And that can be very useful for you. Okay, blah, 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 blah. Okay, which ones are hard here? Let's see. Weather checker right here. Okay, this one's kind of hard, okay? All of these questions exist to kind of poke and prod your knowledge of Lua. It's not just a random blob of Lua put out there, okay? It's trying to get you to remember usually a foot gun, okay? So, right, what do we see every frame? So on update, debug.log, when the following component is attached to an active actor, okay? For our purposes, we can assume that this if statement succeeds. So energy variable becomes 80, right? We then print self.energy, okay, which is initialized to 100. Now, this is not super hard, but it is if you've forgotten that Lua is global first, okay? Lua is global first, which means that when we say energy equals 80, this does not refer to that energy value right there, okay? Energy and self.energy are two totally different things, okay? And this is one of those annoying foot guns in Lua. Easy language. You're kidding me. All right. Okay. Memory usage. Okay. This one is a little bit tough. This one tells you that this code is throwing an error. It tells you what the error is. It also gives you a pretty good hint. The error has to do with self. Okay? If you look through here, the self values are coming through our functions. When self is available, this is kind of a telltale sign that we're dealing with an instance function. Okay? This function might want to operate on data within the table. For instance, name, HP, blah, 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 all that stuff. So we only have a few options here, actually. So we can look at 3. Nothing really wrong with 3. It's just creating a variable. What HP equals 100. Okay. What about 12? What's 12? Debug.log. That looks fine. Okay. Self.name. We'll get question mark, question mark, question mark. No error, though. No exception. Okay. What about 16? So 16, self, progress stats. Remember what that colon does. It calls a function, yes, but that second little dot on top there is the self reference that Lua will send in for you, okay? So progress stats, self comes in, self.stamina. Stamina is defined, and it gets decremented. Okay, looks fine to me. Okay, what's next? 18. 18, huh? 18, self dot. It's dot, so this looks like a static function to me. Okay, it won't be able to use any of the values of the table itself because no self reference is being sent in. Self dot progress battle. Progress battle captures a variable, okay, 10, okay, it tries to use self dot def, and self is going to be nil. It wasn't passed in properly, okay? In order to fix this, we need to change this to a colon, okay? Another one of those foot guns. You don't see this kind of syntax in a lot of other language. In a way, Lua feels like kind of a bit of a rogue language. They go their own way. I kind of love it for it, a little bit. Maybe that's just a bit of Stockholm syndrome, though. Thank goodness it's so easy to integrate. Okay, so we got a good answer there. It's 18. This one requires a little bit more thinking again. We got a pretty buggy component. If I've given you an evil question on any of the quizzes, this is probably the one. Okay? So we've got an actor here. We've got a chatty component, which is defined right here. We can see. We've got a magic number override, 498. Okay? So magic number by default is 0, but here it's going to be 498. Okay? Now, in onStart, okay, we're going to run onStart message, which is hello from onStart, okay? Except, are we actually going to print that? Wait a second. What is onStart message again? What were we just talking about a couple questions ago? It's global. It's not the message here. It's not that message. It is this right here is referring to a variable that doesn't exist. And if you're really good at test-taking strategies, you might get pretty suspicious when 3 of the answers start with nil. Okay? You're a little bit suspicious about that. Okay, so we're printing nil. We got rid of 2 of our answers here. That's happening right away. Now, onUpdate is the next function that's going to run. OnLateUpdate is going to run after it. But here we're doing onUpdate. Now, I'm not sure who wrote this component, okay? Because onUpdate is going to print the message for onLateUpdate. So what are we printing? Hello from LateUpdate, okay? And boom, there we go. We now know our answer without moving forward. But if you want to, you can go to onLateUpdate next, and you can check the magic number. The magic number is 498, which means we're going to print very magical onUpdate message, hello from onUpdate, okay? Yep, there you go.
So onStart message is global, but it seems to be initialized to hello.
Right here, onStart message.
Yeah.
This isn't global. This is just a property of the table.
Yes.
Yep.
But but like that's the isn't that the initial component, right?
Yeah.
And so it's gonna have
Yeah, so this table right here has 4 variables added to it, inside of it. And in addition, 3 functions that are inside of it. A Lua table, you can really nicely think of it as a JSON blob, basically. It's a key value store. It's not much more complicated than that. This is why we need to remember the commas even after functions, which is a bit crazy, okay? What?
Value to me, like, can you explain why it's not, like, the default value for that is not hello from
On start message?
Yeah.
Well, it does begin as hello from on start. The problem is in the on start function, we're not printing this. We're not printing this value. We're instead printing a global that hasn't been defined yet. Thus, we print nil, okay? This is probably the hardest question on the quiz, okay? And you solved this one, you got a pretty good feel for Lua, okay? Blah, 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 blah. Okay, this one is another tough one, all right? Another tough one. Gonna have to make the exam easier than this. Gonna have to. And it's tough, though, because you want to write questions that will really poke and prod certain things you want the students to know. But I think if you poke and prod too hard, if you go too deep, things get a little bit rougher than they should be. Anyway, okay, we've got this table. We're treating it like an array. Okay, these are all the courses you should take next semester. This is based on real life story, okay? Real life data. You should actually take these. Probably not this one. You already took this one, okay? Okay. This operator right here is something you might not have seen. The hashtag operator, the number operator, is a really cool way to basically get length. I kind of wish, this is one thing in Lua I wish other languages might adopt, because it's very convenient. Anyway, this for loop is going to iterate I from 0 to the number of elements in this array, okay? And so we've got a little bit of an issue, all right? We're going to print every other thing in this array. So if I is even, if it's 0, if it's 2, if it's 4, we print the thing. Okay? Now this would be easy if you remember another foot gun of Lua, which is, oh my gosh, everything's 1 indexed. Okay? Which means when we go for 0, we're going to hit nil, actually. Okay, so nil is the first thing that we will hit. We will then do EEX 440, PAT 305, Education 333, and that's it. Okay? And so, another question where you kind of have to remember some things about Lua. If you can remember these things about Lua, programming Lua becomes a real joy. If you don't remember these things, you're going to get wrecked, okay? Absolutely wrecked. All right, what do we got any other tough ones? Okay, this one's pretty tough, okay? This is about getting references to other things across your code base, other components, other actors, all that stuff. A lot of options in here that look like they're almost right, but are not, okay? So for instance, self, actor, dot, get component, okay? And the problem right here is that dot. Actor dot get component implies that get component is a static function, okay? In reality, if you want to get the components on an actor, you'd better make that an instance function. You'd better send that self reference through, okay? So this one's out because of that colon, okay? And also, actually, you don't need, that a colon should be here and the dot should be here. It's actually reversed from what it should be, okay? Get component, you can call this, but you can't just call it willy-nilly. You got to have a reference to an actor, so you can't call it just like this. This syntax is C# syntax. All my 494 Unity devs getting wrecked by this, okay? Actor.find, some actor is great, but this is about getting a Lua component, not an actor, okay? So knowing the difference between an actor and a component is important. Here on the bottom, we find an actor. That looks okay. But then we forget to do the colon, okay? And so we treat get component as a static function with no instances needed, but that's just not how get component works, okay? Okay, so the top one, actor.find, get some actor, use colon to call that actor's instance function get component to grab its components instead of some other actors or all actors' components, okay? And so that's the answer. I'll tell you, some students thought I had made a typo in this question, okay? And you can see why. You can definitely see why, because just a tiny little change fixes it or ruins it. Okay, what else we got? And then this last one is a gimme. Okay, any questions on any of these? Nope. All right, I promise you these questions will get way easier the better you get at Lua, the more you use it. I know you're strapped for time, okay? Just creating the test cases for homework 7 and homework 8, I learned Lua really fast, and now I can pretty much type it from memory. I ran into all those foot guns. I got burned by them a few times, and it doesn't happen anymore to me. Okay? This reminds me a little bit. I used to think that maybe I wasn't a good writer when my essays were stinky. They weren't very good, okay? In reality, when I was having a tough time writing essays, good essays, is because I wasn't putting any time to study the topic, okay? And if you don't care about a topic when you're writing essays, yeah, you're not going to study it. Your essays are going to be crappy. You're going to start resorting to shortcuts, okay? It's going to be really obvious that your paper is half-baked, that you don't really know what's going on. But I'll tell you this. You asked me to write an essay on indie horror game dev right now? Okay, you give me 30 minutes, I'll have 5 pages single-spaced for you, okay? And it won't be half bad either, okay? So this is to say that if you're frustrated by Lua and you feel like you don't understand it, it's not you. You're incredibly brilliant people. It's probably just the allocation of time isn't quite there. If you can get yourself hyped for Lua, all right? If you can get yourself hyped for Lua, you can probably get that knowledge into your head pretty quickly, okay? Now that motivation part is the part that's always really tough, isn't it? Okay. And it's different for everyone, so I will leave it up to you. Okay, so that's quiz 4. Oh, Alex, you had a question, did you?
Yeah, can you go to the one where it's about it's trading performance for memory, I believe?
Yes.
Can you just walk through like why the correct answers are correct? I think I got 2 of these, but not the third. Big development time is the line.
Yes. So you know how in homework 6 you needed to implement the AABB algorithm. You needed to implement a bunch of additional data structures to like quickly in O of one time query in this cell, these actors exist, okay? The idea here is that you often start out with a very simple implementation. Hey, all my actors are in a vector, that's it. That's all you got, okay? Like that's literally all you got. Okay. Well, if I want to know if any actors are close to my current actor, my player, I guess I just got to iterate through them all and check, right? Well, that's super slow. So what do? Well, you create an accelerating data structure. You're going to create and then maintain over time a data structure that allows you to say, hey, in O of one time, I want a vector that just has, or I want some sort of container that just has all the stuff in this region, okay? So that I don't need to do this nasty O of n algorithm unless everyone is literally in that region. That would be nasty. And that's going to come at a cost. You're going to get incredible performance, but those data structures are not free. Memory is fairly cheap these days, but if you're on a console, yeah, you might have to be a little bit careful. Maintainability is difficult too. When you add that accelerating data structure in, you have to make sure that it's always valid. And as things move around, as your game state changes, you have to fix those data structures up. One actor moves from one region to the next, and you have to take it out of one region data structure, put it in the next. Development time, none of this comes cheaply, right? Homework 6 was a tough assignment, in part because of those difficult performance requirements at the end. So none of this comes for free, and really, until you have performance issues, you shouldn't worry about it too much. But that's the rationale for these answers, okay? I've been thinking about how to make the quizzes a bit easier next semester, or actually in a year from now. I think for these checkbox questions, I might literally tell you how many checkboxes are expected. That'd probably help a lot, wouldn't it? Yeah, that would help a ton. So that's what I'm probably going to do. Oh, goodness. You're going to be talking, once you're all in the industry, you're going to be talking to future game engine architecture students. You got to tell them they have no idea how good they got it, okay? The stuff you had to go through in that first semester. Ooh, okay. Anyway, any other questions on the quiz?
Isn't Lua lightweight? Like it's smaller than a lot of languages.
What's that?
Lua's it's lightweight, right? 'Cause it's
Yeah.
smaller than most of the languages.
Yep.
So wasn't there questions on why you would choose Lua and
All right, let's see it.
at the bottom?
Okay, yes. All right, so the question was, why would most people choose Lua in today's day and age versus Python, which is much more popular, versus JavaScript or something like C#? And there's some options you don't have here. So ease of integration into existing C++ code bases, like we've talked about that a few times. That's the reason we chose it for this course. If we'd chosen Python, it would have been a lot hairier, I think, on homework 7 and 8. Extensive library? No, it just doesn't. No, it doesn't have it. Lua Rocks does exist, but it's not nearly what you'd get with NuGet, C#, or Python. I think we talked about that during the lecture. Concise and space-efficient syntax. No, definitely not. Like, Lua doesn't even have plus equals or plus plus. It's lacking a lot of convenient features other languages have. And you have to specify a darn self reference when you're writing instance functions. It's not a super concise language. It has tons of footguns, as we talked about on multiple occasions. So the main answer is right here. Okay, ease of integration. Okay, any other questions? Okay, cool. All right. Well, what do we do today? We barely anyone's working on homework 8, so I guess we can chill a little bit, but we should probably finish talking about Box 2D. Okay, maybe Google will let us finish this time. I had a bit of extra time on Tuesday, so I added some more content. That actually happens. I'll come back to a bunch of these slides in like a year, and I'll read through them to shake my head. Be like, oh, I got to add an example here. Oh, these slides stink, and I'll redo them. The good news is doing that is really cheap because you're just fixing a few slides, taking a few more screenshots rather than making the whole darn thing. And again, the toughest part of making any lecture is the same issue. This is the toughest part of game design and game development. Figuring out what you want to say, what story you want to tell, and how you're going to do it. Actually making the thing isn't so bad. It's knowing what to make. Then you go make the thing, spend all that effort, and then you realize, oh, you made the wrong thing. It's tough. That's the creative process, though. You want to iterate as much as you can to try and avoid the damage that can cause. All right. Okay, so here's the model we didn't quite get through. Good reminder for last time, too. It all starts with that B2 world. Okay, this is basically your sim, your simulation. This is it, okay? This is the matrix. And you are going to start putting things, jamming things into this world. And when you do, that's what's going to bring your physics to life, okay? By the way, I got a little tip for you for Test Suite 1. One of the kind of tricky things, it's not that tricky, but it's a bit weird. You can have a Box 2D world that is simulating correctly. A box is falling, but you're just not rendering it properly. So it actually might take a few experiments, a few tries for you to kind of pair up Box 2D's numbers to your rendering, okay? So that things actually look right. When I did this the first time, you know what happened? I'm going to talk to you more about this in a sec. You know what happened? The numbers say my box 2D box is falling. But guess what? I start rendering it, my box falls upward. I'm like, no way, what's happening? Oh no. In box 2D, the y-axis is positive up. And in our engine, up is negative. Oh no. Oh, why did we do it that way, by the way?
Convention. I just know. Really?
Well,
screen coordinates were like top
so
0, 0.
both are convention. Basically, we got SDL as a super important dependency first.
Oh, gotcha.
And so that's how we did it.
Okay.
SDL is up negative and box 2D is up positive. Oh, why didn't they talk? All right. Oh, well. Okay. It's not that bad. You can solve this with one character on your keyboard. Okay. I won't tell you which one, though. All right. Okay. A box 2 world, and this is something you have to remember, otherwise things just aren't going to start doing anything. A box 2, B2 world has to be simulated. You have to tell it to simulate. You tell it to simulate for a certain amount of time. You could, for instance, you could tell it to simulate for an hour. And, it's not going to be super useful, but if you want to kind of get a feel for what things would be like in an hour, maybe you can do that. Okay? I think that's how time step works. But in reality, you probably just want to give it, 1/60. Okay? And that's what we have you do here. We want you to use this code. Otherwise, we could risk some desynchronization issues, some off by 1 pixel errors. We don't want that stuff. Okay? Velocity iterations and position iterations, these are kind of your measures of accuracy and quality in your sim. These are pretty high quality numbers, okay? And depending on what you need, you could lower that. Maybe on a mobile device, you might lower these numbers so you can run a bit faster. But these are what you should use. And if you try and lower them to run faster, you're probably going to get blown up, okay? All right. B2 world, inside of it, you want things. You want cubes, spheres, whatever. You can do a B2 body, okay? B2 bodies. You're going to create several of them. These are basically the equivalent, the analog to your rigid body components, okay? If you've used Unity or Godot, these are rigid bodies. And Box 2D just calls them bodies, okay? I don't know. I don't think Box 2D supports non-rigid bodies. So they're just like, yeah, they're just bodies, okay? I don't think Unity supports deformable bodies by default either. So you wonder why they went with that terminology. Anyway, a body doesn't actually have any information. In fact, if you take a B2 body like these and you don't give it a fixture, these B2 bodies will not do anything. They will not simulate, okay? They won't fall. They won't collide. They won't detect collisions at all, okay? Until you give more information to Box 2D. You need to give it a fixture, okay? Fixtures are basically, you can kind of think of them as collision shapes, okay? If you're from Unity, you'd call these probably colliders, okay? And on these fixtures, you can really define a lot of very good stuff like friction and stuff like that. Oh my goodness, there's a lot here, okay? For a collider fixture up top, you can set is sensor. Okay, in Box 2D, a trigger is a sensor, right? Terminology difference there. You can set your shape, okay? You can set your density, your friction, your bounciness, called restitution. The bottom one there is pretty powerful. We're using the .userdata.pointer piece of data field to basically store some information for later. You're going to see why that's necessary soon. But basically, we're storing a pointer to our actor inside of that value. Have you ever seen a reinterpret cast before? All right, you're learning a good bit of C++. I hadn't seen it before much either. I don't mess a whole lot with like reinterpreting pointers in most of my work. But here I'm kind of required to do it. by the way Box 2D is designed. Okay, so reinterpret cast is basically saying, hey, okay, we know that you want to store this actor star pointer, okay, it's a different data type, inside of this dot pointer property, this field. Now, normally you wouldn't be able to do that. You know why? Because this dot pointer field is actually a uint pointer t data type, okay? And this is an actor star data type, so it's not going to work. But you know what? All pointers are kind of the same size. So can we? And the answer is yes. The answer is yes. And so that's what we do, okay? Basically reinterpret that actor pointer to instead be a uint pointer t, and do it because we need to store it on the fixture. We have to, yes.
Is that something like a void pointer?
Yeah, basically. And so that might look a bit confusing. Now you're good though, okay? I don't know, maybe it'll show up in the quiz, we'll see. Okay, these two ones up here are big deals, okay? I won't explain them to you too much. You can do a little bit of your own research, but mainly their big win is going to be performance related, okay? You can tell Box 2D to say, hey, this body, right, with this fixture should never collide with this fixture, okay? Does that sound familiar to anyone? The topic of layers is a big deal in Unity, collision layers. You can probably deal with some of this without using category bits and mask bits, your filter property. It's going to be slower though, okay? Because you'll have to handle it in a custom fashion, ignoring collisions. Instead, Box 2D could just do it. Also, Box 2D should have an easier time and compute the next frame more efficiently the less work you have it do. So setting these bits can be super valuable, okay? Basically, category bits right there is a value that basically it's kind of a binary value, and you can use it to say I'm in category X. And if I'm in category X, you can then use mask bits to say I don't want to interact with any other objects that are in category Y, okay? And this is how you can get certain things to not collide with each other in Box 2D, okay? A body may have multiple fixtures, and this is important because you can have actors that have a trigger and a collider, okay? So you might have to add multiple fixtures, right? One good example would be a box character that has a box, collision volume. Okay, so we're going to give it a fixture. We're going to make it a collider. So we do up top. We give it a box shape. Good. But we want to detect when certain NPCs are close to the player. So we're also going to give it a very big radial trigger, okay? That is on the actor as well, okay? And that could be pretty useful. Though I'll be honest, in that case, I would just write some Lua code to constantly compute how close we are using the vector2.distance function that some of you on Homework 8 have already done. Good for you. Well done. Useful stuff. Okay, blah, blah, blah. Yes, I explained all this already. Yeah. MISC physical properties, yeah. Useful for IDing fixtures later. If you don't do this last one, you will struggle to map your fixtures to the actors that use them, okay? So you want to do this. Anyway, your fixtures are almost certainly going to have a shape, okay? And your fixtures are going to have a shape, and that can be decided by whatever you want to do. You create a new, B2 polygon shape, B2 circle shape, box shape, whatever's there, and you can change how your thing will collide with the environment. One gotcha that I'm thinking about, tell me this, what do you do if you have an actor that has no collider and also has no trigger? But you want it to move around. I don't know, because you want the gravity, you want the acceleration, the physics, the velocity. Easy to imagine it happening.
fixture, a new fixture.
Kinda, yeah. So what you do is you give it a phantom fixture. You have to give it a fixture. Otherwise, it won't simulate. That's very kind of frustrating. But you give it a phantom fixture. A good phantom fixture is going to be one that's super small. It's going to be one that is probably a trigger, so a sensor, so it won't physically collide with anything. And you're going to give it some mask bits and some category bits that prevent it from ever colliding with anything else, ever. And if it does, in your response code, your collision detection code, you just ignore it, okay? So anyway, that's a little gotcha you'll have to experiment your way through a little bit, okay? In other words, we basically recreated a ton of the fields and properties that you find in a modern game engine. Okay, I'm not kidding. Unity paid someone hundreds of thousands of dollars, almost certainly, to add Box 2D to their game engine. Now, I'm just saying, they probably had way more time and resources than you do. Okay? So I'm not saying go apply to Unity, but you should probably consider it. Okay? Not too many people doing what you're doing. Okay. Sometimes we want to detect and respond to collisions in some sort of super custom way. Okay? We don't want to just see the physical interaction. I want to bounce. Something like that. Okay? Well, we're going to have some new lifecycle functions on Homework 8, right? You love adding those, right? Getting the timing perfect, making sure it happens on this frame and not the next frame, or wait, maybe it's supposed to be on the next frame and not this frame. Oh, geez. Okay? Well, it's important stuff. Look at this GIF right here. This is your final test case in the course. See that yellow block? Boom, we go up. Okay? That is not a normal physical collision. Okay, that is some souped up logic. All right, we just made a springy, a bouncy block. Okay? All right, boom, right there. We need to respond to the collision of our ball and our yellow blocks with some Lua logic. Okay? Here is what those yellow blocks look like. Here is the actor template. It's bouncy box, it's called. It's got a sprite renderer using box 3, which is the yellow box. Okay? Negative 999 means it's going to render on top of everything. Can't hide these boxes. It won't render on top of UI, though, probably. Okay, second component is a rigid body. So this box has its own rigid body. That's necessary so that we can actually detect a collision has occurred in the first place. Otherwise, box 2D doesn't know that that yellow box is even there. Okay? We have a rigid body. It's set to kinematic. Does anyone remember what kinematic means? Oh, this is a quiz question for sure. Yes.
Its movement's only controlled by scripts, not
Yeah.
the physics system.
Yeah. Think of it as like a manually controlled physics body, okay? It doesn't get simulated so much, and you only move it with code, okay? With warping, set position, okay? Teleportation. But it's not going to fall with gravity and you can't push it, all right? Then static is when nothing can change its location, even teleporting, even set position. And then dynamic is it's just falling, it's simulating, right? It's acting like a physical object, okay? It had its has trigger set to false. This is a really interesting question in API design, okay? You might have expected me to design this with, let me see, has trigger kind of being false by default, okay? Well, it's actually not. By default, all of your actors that have a rigid body will get both a collider and a trigger fixture, okay? And this is because one of the toughest things in Unity that blows everyone up is when you first try and learn how to figure out Unity collisions. And you have to somehow remember and know to put on multiple components and then write your function in just the right way. Well, in our engines, it's going to work from the word go so long as you add a rigid body, a single component, and then write on collision enter, on trigger enter. It's just going to work. This is less performant, right? Because people will default to having more than they need. But from a user experience perspective, it makes our engine easier to learn and use. They can always turn it off later if they need better performance. Anyway, we are turning off the trigger because we don't care about the trigger here. We still have a collider though, by default. And then we have one more component called bouncy box, okay? And what this does, you can see it right here. Might have to squint a little bit if you're far away. This bouncy box component has written the on collision enter lifecycle function, okay? It takes not just that instance function reference to self, but it also takes a collision object, okay? This collision object will contain some nice goodies for you, right? You don't want to just know that a collision has happened. You want to know more. I want to know, yes, a collision has happened, but with who? Who collided with me? I'm the bouncy box. Who collided? Right? You can see us using this collision data structure here. We can check if collision dot other, and other is basically an actor pointer, colon get name equals player. So if we collided with the player, then we want to do this logic. Grab the player's rigid body. Get the current velocity of the player. Okay? Calculate the new velocity of the player, which basically just replaces the y component of the player's 2D velocity vector with negative 15. Yeah, that'll make you go up. And then do RB colon set velocity to actually use that new velocity we just calculated. Boom, that sends us flying upward. Okay, nice. Wasn't that hard? Didn't take that much time. Okay. All right, on trigger enter, right? Triggers are a big deal too, okay? So you've seen the bouncy blocks, but look at those finish line blocks, okay? Watch, we're gonna jump up and the HUD is gonna change because we finished the game, okay? We're gonna hit the finish line at 23 seconds, boom, done, finish, okay? And then we restart, okay? Those things right there. We want to detect that a collision has occurred, but we don't want to like smack into it, right? We want to get the collision information without actually having the physical ramifications of the collision, right? This is often referred to as a trigger. Sometimes it's invisible. It's very common in a FPS game, for instance, a Halo, to put invisible triggers in the environment so that when the player runs up here in this part of the map, oh, this enemy ship is going to come down and start spawning enemies, okay? And they're just triggers littered throughout your environments to create a certain experience, a narrative, okay? Here's the setup for that object. I gave you the wrong one. Oops, it's bouncy box again, okay? I got this right, though. Okay, the victory box, which, so basically this is a rigid body that is a sensor. Okay, it's a trigger. So has collider colon false, and then the trigger is there by default. Okay. Okay. On the victory box component, which all of those have, on trigger enter is written. It has the same collision data structure. We check if the player has touched us. We publish an event called event victory. Okay. This is the pub sub design pattern again. We're not grabbing a reference to the player so much and manipulating the player or the HUD, right? We're not grabbing the HUD actor, grabbing its components and manipulating that component. We're really just kind of publishing an event. Hey, a victory happened. That's it. We don't care if anyone uses that event or not. But it turns out the HUD does use that event. The HUD has a component that subscribes to event victory. And when it comes through, it changes the text that it renders. Okay? Boom. There we go. Okay. So, on the C++ side of things, getting this all hooked up is where a lot of the work in Homework 8 is going to come from. Okay? And it is, it's a little bit funky, but it's not too bad. Okay? Not too bad. Box2D is a great engine, and it will detect collisions for us, okay? And our mission here is really to kind of pass that data through to our users who are writing their code in Lua. Okay? And so what you're going to do in order to get some of your C++ logic responding to collisions, and this is a pretty weird approach, but it kind of works. This is a pretty flexible approach, so it's pretty smart. What you have to do is you need to create your own new class. That class must derive from B2 contact listener, okay? And your class must override two functions, begin contact and end contact, okay? Now this looks a bit familiar if you've ever used Unity, right? Okay. This contact variable right here, this B2 contact variable, will contain all the information you need about which fixtures have collided, okay? How fast were they moving when they collided, okay? What's the normal of their collision, and stuff like that, all right? Now, after you've created this class, you need to actually use it. And to do that, you create a new instance, okay, of your listener, and then you need to register that listener with your physics world, your B2 world, okay? You do that, and you're good to go. These functions will start to get called automatically whenever collisions happen, and you can just respond to them, okay? You will eventually have to implement raycasting, and the approach is very similar there, okay? Raycasting, super powerful. Look forward to it. I want to talk to you a little bit about some foot guns you're going to run into, and I'm also going to emphasize. Okay? Because there hasn't been all that much of it in the world of 2D or 3D graphics. I guess there's been a good bit, but there's still some things that slipped by, I guess. One of the pains of having diverse dependencies, many dependencies, is that sometimes they're kind of incompatible with each other. Okay, and you have to fix that, and it's a bit annoying, all right? So our engine is over there on the left. On the right, we have Box2D, okay? So their x-axes are similar. They're the same. No big deal. That sounds great. However, positive y points downward in our engine, and in Box2D, positive y points upward. Now, I really wish that we could just roll with this, since this seems much more natural. But it's not the case. You have to take on the burden, the complexity of making it feel natural for your users. Okay? So consistency is what you are going to work on so that your users don't have to deal with this flip-flopping. They don't have to get themselves confused by it. Okay? You'll get confused by it instead. That's all you have to worry about, fortunately. Except for rotations. Oh my goodness. Okay? In our engine, right? Rotations are clockwise. All right? You say I want to rotate 270 degrees, it's going to look like this in our engine. Okay? That's the standard. Okay? However, in Box2D, it's counterclockwise. Why did they do this? Maybe it's because they really like the unit circle. Okay? In some math circles, this is how you typically do it. But what's even more is that while we use degrees for all of our rotations, they're kind of user-friendly, I guess, a little bit less scary than radians. Box2D uses radians, okay? And so you got some converting to do. And the spec is going to help you a bit here. I think we even give you some code to make sure we don't get some off by 1 pixel errors because you're dividing in a slightly different way. Or you forgot to put like the F at the end of your number, so you're dividing a double accidentally instead of a float. Yeah, it's a little bit annoying, isn't it? But again, the point here is that you take on that complexity and basically act as a shield for your users, okay? You create a consistent environment for them to think through, make it as simple as possible, as consistent and straightforward as possible. Then on the back end, we get paid the big bucks, hopefully, to make all of that just work, okay? Even when everything's disparate and nasty, all right? Does anyone have any questions on Box 2D? I think you're going to like this a lot. I hope. If the off by 1 pixel errors start to pile up, maybe you won't like it so much. But you're going to be done in less than 2 weeks, okay? Going to be out of here. You're going to be focused on the exam, and then after that, it's pretty much smooth sailing. Okay, you can focus on your other courses a bit, just enjoy the lectures. I probably will offer some extra credit for people who show up for our guest lectures, because I really don't want, like our guests, I don't want, the lead programmer at Stardock to show up and, hey, we got, no one's here. No one's here. Austin, what happened to your course? And I say, oh, they're watching. It's just, they're watching late. And, gosh, not as satisfying at all. Okay, not as satisfying. Okay, well, all right. Okay, got about 20 minutes left. I think I want to give you a little bit more information on the topic of PubSub. And you're going to have to forgive me. Then we'll maybe end a little bit early. But when I say event.publish, okay, when I say event.subscribe, this is a pretty common design pattern. Has anyone heard of event-driven programming? Okay. Event-driven programming, as far as I understand it, is all about those callbacks. Okay, you write functions, you don't necessarily call them, but you do register them to be called at certain moments, okay? This can be nice. It can be a nice, convenient way to think about state. Once those callbacks are set up, it's just they're going to run at the right time, and let's rock and roll. In a way, you can think of it as a lifecycle function you're setting up, okay? This assignment that you're working on is pretty lengthy, and toward the end, one of your final objectives will be to implement an event bus, aka the PubSub, publish, subscribe design pattern. Okay? It consists of 3 functions. Okay? Event.publish, this takes an event type, a string, and it takes a Lua ref, some sort of object. Maybe you want to pass a table through, maybe you want to pass a string through or a number. You can pass anything through, okay? Now, when you publish something, who is listening? Who is subscribed to that thing that you just published? If no one is, what happens? Nothing. It's like you it's like you wrote a newsletter, but you got no one registered and subscribed to your email newsletter. You still sent it out. No one read it, okay? But maybe you're still okay with that. Maybe a little bit sad. No big deal, though. However, if someone wants to subscribe to your email newsletter, they can do it via event.subscribe. They're going to subscribe using that same event type string that was right here. And the LuaRef component, this right here is actually, it's got to be a reference to this table, okay? This syntax is a little bit funky, but this isn't super hard right here. All you got to know is that whenever any sort of component calls subscribe, they're going to send in a reference to themselves. That'll make implementation way easier on your end, like 1,000 times easier. Okay, I was trying to implement it like this because this looks really nice, right? Nope, nasty. If you do that, it's very hard implementation. Not impossible, but too much for me to ask of you. And then you're going to register a function, a callback function to actually handle this event object when it comes through. So this function right here in your subscribe call is the thing that's going to get called whenever someone publishes the event that you've been subscribed on. Okay? Now, unsubscribe is a function that basically allows you to say, hey, I'm done with this newsletter. Unsubscribe me, please. And then your function will never run again. Even if that same event you used to be subscribed to comes through, you're not going to respond to it. You're not going to do anything, okay? Now, this is actually a pretty popular pattern, and a lot of people like it quite a bit. Let me see here. One of the reasons, hopefully I got the lecture slide. Yeah, this is going to be in C# because it's a 494 slide deck. But PubSub is a thing that's really useful for a lot of people, okay? Basically, you know how we can have our are components reaching out to other components. We can have components that grab a vector, but then grab an actor. And then on that actor, they grab a component or two and they mess with those components and they mess with their values, call functions on that component. It's just very nasty. Very nasty. And this is what you would call typically a hard coupling, okay? Suddenly we have a component that literally has it requires the knowledge, it requires the existence of this other component to exist itself. In other words, our components are getting too tight. They're getting too close, okay? They're messing with each other. They're dipping into each other in a way you don't want, okay? And this is some of what we have here, okay, in C#. All right? If we were to have this C# code in our code base, right here, if the player system were deleted from our code base, what would happen? So in our code down here, we have player system dot on player scored, okay? Same thing here. What happens if our player system just disappears from the code base? What happens? What happens? It explodes. It won't compile anymore. You know why? Because player system suddenly becomes an undefined symbol. All right? And so I want you to take a moment because this should disgust you a little bit. It feels really weird. Wait a second. I've got a UI system and I've got a toast system. If you don't know what a toast is, it's those little notifications that come up in the corner of your screen or your operating system. A quick little message pops up, goes down. Simple stuff. I got a UI system in my game. It's pretty good. I got a toast system in my game. It's good. But it breaks if I don't have exactly the right player system. What? Wait a second. Why do I even need players? What if I want to make like a film experience that doesn't have any players? It just is kind of like an interactive movie. I still want to be able to do toasts, right? And so this is already spaghetti. You might not have realized it. But having components that mess with each other and talk to each other a little bit too closely, that hard coupling can get you wrecked, okay? This is kind of a very moderate example. The classic one is like you're writing your own physics and collision system, which is like a huge topic. But you start putting like audio code in, like embedded into your physics calculation code. Like amongst all the math is a bunch of calls to like jump.wave. It's like, wait, what? That's nasty, right? Why is my physics logic, why is my physics system hard coupled to a specific audio system? And the answer is it shouldn't be. What should happen is that your physics system emits certain events, and maybe an audio system out there catches it somewhere, but maybe it doesn't, and who cares, right? That's how you want it to be, all right? Okay, so how do you deal with this, right? We're going to get rid of these links, okay? And now these will compile just fine. The problem is we're not really going to accomplish our objective, okay? Maybe we want some toast message to happen when a player spawns in. Well, it's not going to happen now. We need information from the player system somehow so that the toast system can do its job. Here's the technique. Instead of hard coupling every system to every other system it wants and needs, we're going to put one common coupling in the center, okay? This is the event bus. It is responsible for passing events between systems, and sometimes people subscribe to those events, and those events have an impact, and sometimes no one's subscribed, okay? And no one cares, all right? So now what can happen is that the player system, instead of calling into the toast system or the UI system, it just emits an event and it's done. It's chill, okay? Sends the email out. It's done. Maybe someone listens, maybe someone doesn't. Currently, no one is listening. Absolutely no one cares about this event yet, okay? The score event goes into the event bus. Now, fortunately, at the last second, our UI system subscribed to that event, okay? And the toast system also subscribed to that event. You ask, which event? Oh, I want to respond to only the score events, please. In particular, I want the scored function to be the function that processes that event as it comes through. And you can see, there it is. It comes through as this parameter right here. Okay? So the event bus first gets passed to UI system, probably because UI system subscribed first. That's how it works in our engine. And then the toast system also gets passed that same object so it can do its thing as well. Okay? All right. So how does this work under the hood? In C# at least, it's basically a dictionary. And this wouldn't be a bad idea for you to do as well. Okay, dictionaries are super useful. You can decide if you want to have an unordered or ordered dictionary, whatever you want to do. You're probably going to use a dictionary in C++ at some point for this. This event bus at any given time could have a lot of subscribers for different types of events. For instance, score event type, the score event could have 3 subscribers on it. And you can see 3 functions right there from 3 different systems, okay? But you could also have a KO event. And maybe only the UI system cares about that, so it can render the cool KO message, right? Or maybe you have a new player event, and you got the UI system because it wants to print a new player text as well, not just when someone's KO'd, but when someone enters the match. But the audio system has also subscribed because the audio system wants to play some music or a vocal. Now, player 1, ready, right? The one nice thing about being sick is that my voice is maybe a little bit lower than it normally is. No, that's not good. Okay, what's a good Batman voice? I'm Batman. Where's the Joker? Okay. Anyway, let's get on. 498. Okay. All right, event bus is pretty cool. All right. Hey, my voice was much worse last showcase. If you were at the last showcase event, you heard my voice like super crusty. Some people really like it, so I was a little bit salty when it went away, actually. Some people were big fans. Okay, flow of events here are thus. Okay, your event bus.publish is called from somewhere. And this is C#, but I'll tell you, this is basically one for one what you're going to do in your C++ as well, in your Lua, okay? Someplace event bus, in your case event.publish is called, okay? The event is going to reach your broker. In your case, it's going to be in C++, okay? The broker uses that event type to basically look up all the subscribers, okay? Oh, we got an event KO, huh? Anyone want that? Oh, yes, 4 people want event KO. We got 4 Lua refs, okay? 4 Lua refs representing functions, okay? In reality, you're probably going to do something like a pair of 2 Lua refs because you don't just need a function, you need the self reference to call that as an instance function. Oh, that blew me up. Okay, that blew me up for a couple hours. Okay, all right, so we found it, right? The score event is here, so let's look at that score event list. And you're going to one by one call each of the subscriber functions and send in that score event. Okay, boom. Call UI system.scored, call toast system.scored, call particle system.scored. Okay? And that's how it goes. One really cool thing is that you can actually have multiple producers of different events and the same event if you want to, right? And so you can have this kind of nice architecture where, at least for the most part, most of your systems don't really know or care about each other. This makes them pretty easy to move around. It makes them a lot more portable to other games, other engines, okay? The big takeaway about PubSub is that for publishers of events, like the victory box, the finish line box you just saw on the last presentation, right? They think to themselves, maybe someone will listen to my event going out and respond to it, but, no worries if not. Who cares, okay? It's all good. Okay, the subscribers are thinking similarly. It's great if an event comes through. I'm going to respond to that event if it comes through, but Just chilling, just sitting here. Okay, no big deal if nothing comes through. Okay, which is to say that pub sub just kind of makes your code chill out. That's one of my favorite ways to phrase it. If you get addicted to pub sub and you have just thousands of events, many of them that feel very similar to each other, if you have chains of events where like one event is being published and that causes another event to be published and that causes another event to be published, oh God, okay? And everyone at Wolverine Soft Studio knows that pub sub isn't a cure-all, especially in cases like that. But especially if, for instance, you've got a combat system and you just kind of want to get some information to the UI somehow. Oh, this is just a wonderful way to do it. Okay, great way to do it. It's going to really simplify your code base, make things look a lot nicer, simplify your logic, make it much easier to read. And yeah, have a good time, okay? You've got loose coupling at this point. Your systems can interact, but they're not hard coupled to each other, okay? You can separate them without things exploding. You can bring them to new projects without other things being there. You're all good, okay? All right. Any questions on pub sub? We got about 9 minutes left. Okay. All right. Everyone, yeah, thank you for tolerating my my voice. And I tell you, I'm going to put my mask on for office hours. I don't really want to get super close to you today for obvious reasons. So, I'm tempted to just say I'm going to go home and I'm going to do office hours remotely. What do you think I should do? Should I do that? Push office hours back half an hour? Do remotely? Probably going to do that. I don't like the idea of being over your shoulder with this stuff going on, okay? So that's what we're going to do, all right? So you can go home if you want to. You can hang out here with each other if you want to. Support each other. This is a tough course. As long as you don't copy code, good to talk about stuff, okay? Not a big deal. That's what the quizzes and exams are for. And, yeah, I'll see you next time, okay? Thank you for coming. Yeah.
So the event bus is just like basically like something that has all the data from all different components that just runs in order.
The event bus has a mission. It must call certain functions when certain events come through.
And
As a result, your event bus is going to need to store some information.
okay, so
It's going to need to store Lua refs. In particular, it's going to need to store Lua refs representing the function that needs to be called.
okay.
But remember, in Lua, it's a bit of a pain,
Yeah.
right? You have to also be able to send that self-reference through. So you got several things you're going to have to store and keep track of to make that event bus work.
So in your example where like all things are pointing to the player component, you brought in the bus because what happens if the player component does not exist. But if the player component does not exist, you'll have the same problem in the bus because the player component value does not exist in the bus. So what value will it use?
So that's okay. So the bus itself is written pretty cleverly. It uses some form of templating, okay? And kind of compile time polymorphism to basically say like, the event bus does not know that the player system exists either, right? Now, the player system knows an event bus exists. An event bus has to exist,
Yeah.
right? Here's a way to think about it. We've solved our hard coupling issue
Okay.
where a bunch of our systems are hard coupling to our other systems. And the way that we solved this is full of irony. You know how we solved this?
The component to the same system.
Bingo!
Yeah.
By hard coupling all of our systems to one system, okay? Which is
So in some way they're all connected to each other too.
not quite. They're all hard connected to the event bus.
So,
The event bus isn't hard connected to anything.
okay. Yeah, no, but like I mean, if you have like component X, Y, and Z all like connected to a bus and X
Yep.
is in the bus, X can access components of Y and Z. right?
What's that? Sorry.
You have X, Y, and Z, and
Yep.
they all are connected to the same bus.
Okay, X, Y, and Z, 3 different functions.
Yeah, three different functions.
Okay.
And now if X wants to use some property of Y and Z, X can.
Okay, so X wants to use some property of Y and Z.
Yeah. Get it? Use like how you have like player, UI,
Oh.
things like that.
So this is the explanation right here. So the event types are also something you need to be portable. So, for instance, this network system is going to publish a disconnect event,
Yeah.
right?
I'm not gonna.
And this system publishes a score event.
Yeah.
In order for UI system to use this information, yes, in our code base we have to have a common definition of score event. Okay, and we
that
also
that should be inside the event bus.
you might decide to do that. You could decide to do that if you want. What I usually do is within each project, I'll have like a standard events script, standard events.cs in C#
Yeah.
that has my list of events
That you
I
want.
care
Okay,
about.
yeah.
Sometimes I do bring that along with event bus, and then sometimes I edit it and mess with it a bit.
Okay, yeah, that's nice. Yeah, that's good.
That's how it
good.
goes.
Thank you.
Yeah.
Thank you.
Yeah, in Lua, Lua is not statically typed. So in Lua, everything is a little bit mushier,
I hope I don't.
and we don't have to worry about that as much. Okay? We don't need a standard events
Okay.
folder or script.
Yeah. Okay.
Yeah.
That works.
Okay.
Thanks, Austin. Thank
You're
you
welcome.
for coming to lecture with your voice.
You're welcome.
Yeah.
Okay, everyone on the stream, take care. Have a good one. Stay healthy. Okay? I'll see you later. Bye-bye.